You walk into a machine shop, any machine shop. The air is filled with the hum of machinery and the smell of metal and oil. What's the one tool you're guaranteed to see? It's the heart of the operation. Chances are, it's a milling machine. These machines are everywhere. These beasts are the backbone of manufacturing, turning blocks of metal into everything from engine parts to surgical tools. They are indispensable. Without milling machines, our world would look a lot different. Imagine a world without precision-engineered parts. Now when I say milling machine, I'm talking about a whole family of tools. Each has its own unique capabilities. Each one is designed to cut metal with incredible precision. They can handle the toughest materials. They use rotating cutters to shave away material, kind of like a super-powered chisel. It's a marvel of engineering. The result? Perfectly smooth surfaces, intricate slots, and parts that fit together like a puzzle. Precision is key. Whether you're talking cars, airplanes, or smartphones, chances are a milling machine played a part in making it. They are everywhere. These machines are essential for creating the complex shapes and tight tolerances modern manufacturing demands. They are the unsung heroes. And trust me, the folks who run these machines, they're artists in their own right. Their skill and precision are unmatched. So, how does a milling machine actually work? Let's break it down step by step. At its heart, you've got a spindle, which is crucial for the machine's operation. That's the rotating part that holds the cutting tool, allowing it to cut through the material. The workpiece, the piece of metal you're shaping, is securely clamped onto a table to ensure stability. Now this table can move in 3 directions, left and right, forward and backward, and up and down, providing flexibility. Here's where it gets interesting and quite intricate. By carefully controlling the movement of the table and the rotation of the spindle, you can create all sorts of shapes from simple to complex. Need a perfectly flat surface? No problem. The milling machine can handle that with ease. How about a groove or a slot? Piece of cake for this versatile machine. Milling machines are all about controlled material removal, ensuring precision and accuracy. Of course, there are a bunch of other components that make all this possible, each playing a vital role. You've got motors, gears, and bearings, all working together to provide the necessary power and precision for the task. And let's not forget the coolant system, which keeps everything cool and lubricated during the cutting process, ensuring smooth operation. If you found this breakdown helpful, don't forget to like this video, and subscribe to our channel for more insights into the world of milling machines. Just like any good tool, milling machines come in all shapes and sizes. You've got your basic drill presses, which are great for simple drilling operations. Then you've got your more advanced vertical mills, named for the vertical orientation of their spindle. These are your workhorses for everyday milling tasks. But wait, there's more. For larger and more complex parts, you might turn to a horizontal mill. These bad boys have a horizontally oriented spindle, giving you more flexibility for certain cuts. And for the most demanding jobs, there are CNC milling machines. These are computer-controlled, allowing for incredible precision and repeatability. The type of milling machine you use depends on the job at hand. But one thing's for sure, no matter what you're making, there's a milling machine out there that can get the job done. Section 4, Milling versus Turning, 2 ways to shape metal. Now you might be thinking milling machines sound pretty similar to lathes. And you'd be right, they're both essential tools for machining metal. Each has its own unique capabilities and applications, but there's a key difference that sets them apart. In milling, the cutting tool rotates, and the workpiece stays relatively stationary. This allows for precise cuts and intricate designs. In turning, it's the workpiece that rotates, while the cutting tool remains stationary. This method is ideal for creating symmetrical objects. Think of it this way. Milling is like using a chisel to carve away at a block of wood, allowing for detailed and complex shapes. While turning is like using a lathe to shape a piece of clay on a potter's wheel, perfect for creating round and smooth surfaces. Both techniques have their strengths and weaknesses, and the choice between them depends on the specific requirements of the project. Milling is great for creating flat surfaces and complex shapes, making it versatile for various applications, while turning excels at creating cylindrical parts, which are essential in many mechanical components. Often you'll find both milling machines and lathes in the same machine shop, as they provide complementary capabilities. That's because they complement each other, allowing machinists to create a wider range of parts from the simplest to the most complex. Section 5, ready to go deeper. So, there you have it, a crash course in the world of milling machines. We've covered the basics, but trust me, there's a whole lot more to learn. In part 2, we'll dive deeper into the world of milling, exploring advanced techniques, tooling, and applications. Get ready to get your hands dirty. We're going to explore the world of computer numerical control, or CNC, milling, learn about the different types of cutting tools, and see how these amazing machines are used to create everything from aerospace components to medical implants. Stay tuned.